Okay, day 11. Cosmic expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up? The researcher has collected a bunch of data and compiled the data into a single giant image. The image includes empty space and galaxies. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. In the above example, 3 columns and 2 rows contain no galaxies. These rows and columns need to be twice as big. The result of a cosmic expansion therefore looks like this. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. For each pair, find any shortest path between the 2 galaxies using only steps that move up, down, left, or right exactly 1 dot. Let me guess, this is going to be a giant spaghetti. Bruh. Okay, let's do some recon work. How many pound signs do we have here? 438. Awk, loop over lines. We're going to learn how to do some awk. Okay, if we transpose it twice, we should get the same input. We do. Oh my god. Okay, so our solution is going to be a little goofy. It's going to be like, we're going to go into something called expand. We'll call it expand universe. So we're going to read our lines. If grep q. So if we don't have any galaxies, then we reprint the line, and we still print it here. Okay, so that expands, right? Now check this out. Now we can transpose our input and expand it the other direction. Our universe is expanding, and now we just put it back to the way it was, and we've expanded the universe. How cool is that? So what's the next step? So the shortest path, this isn't actually a pathfinding problem because you can only move up, down, left, right. So this distance is the same. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. But do you know what else is 9? Is going 1, 2, 3, 4, 5, 6, 7, 8, 9. So all we really need to do is add together the distance in the x direction and the distance in the y direction, and we'll get the total distance between any 2 positions. The hard part of this problem is creating the pairs. Let's make a new function called galaxy list, and let's just do a really simple loop. We're going to do another one where we read 1 character, and we have to do a dumb check here to say if it's nothing, then we continue. This will walk all the characters. This is going to equal to 0. This is equal to 0. We're counting our position. If char is equal to, we echo row column. Oh, there we go. So we have a list of galaxies. We need to create a list of pairs. Make a function that does permutations. I in... All right, let's see what this does. 9. It's not exactly what I wanted. I equals 0, I less than len, I plus plus. Okay. We do another loop inside. J equals I plus 1, j less than len. Done. Galaxies I and galaxies j. Okay. So this is the permuted list. Now we want to turn that into, I don't know, we'll make a new function called distance. This one is going to do a sed. So we're going to grab from the start of the line to the end of the line. We want 0 to 9 plus capture group. We can simplify this. We can just do not comma. followed by a comma. So 4 numbers. This one's not space. And this one is just anything left over. So what did we say our math expression was? We're going to take the row minus... So 1 minus 3 and 2 minus 4. We add those two numbers. So this is our expression. Go that into BC. We don't have ABS. We just do like echo this. That works. Okay, that's cool. And then we'll just go into sum. 374. Is that the right answer for the sample? Sure is. Input. Uh-oh. Oh, we got a number. That ran pretty quickly. This is, I'm pretty happy with this one. This is a cool solution. Look at this. We print the file, we expand the universe, we flip the universe on its side, we expand it again, we flip it back on its side, we find all the galaxies, permute them, calculate the distance, and then add it up. Like, it can't be more readable. Literally cannot. You're excited for part 2? I'm scared. What is part 2? Let's see. The galaxies are much older and thus much farther apart than the researcher initially estimated. I knew they were going to do something like this. Now, instead of the expansion you did before, make each empty row or column 1,000,000 times larger. That is, each empty row should be replaced with 1,000,000 empty rows, and each empty column should be replaced with 1,000,000 empty columns. No problem. We'll just do it. I'm not afraid. Okay. So how are we going to do this? Yeah, you could check how many expansions happen before your row and then add those to your index. We could just keep like some data structure of where the expansions are. We can call these the E rows and the E columns. So we need some sort of variable that's like direction equals 1. So we start by we're expanding row, and then we're expanding columns. So instead of doing this insane thing, if direction equals rows, else, so what do we want to do here? We're going to keep a variable of our index. And the way I want to keep track of this, just so that it's easy, we have like a lookup table. We can local I for I equals 0. I less than or equal to index, E rows I plus plus. We're going to do the same thing down here. So it's going to be E calls. Let's do this on this sample. Does this work? Expand universe. We don't need echo line anymore. We're done with that. Actually, we don't need to print out I. Why are we doing this? We can just print out the thing. Okay, that gets us a bunch of numbers. I think we're going to have to just take this out of its function, sadly. We need to go through all of our... Are we just going through the file again? We go through the file. Right, so first we need to get the list of galaxies. So we can do galaxy list. We have to inline all of this because of scoping issues, sadly. Local can only be used in a function. Where am I trying to use local? Here. We could save this one to our variable. Okay. We have a galaxy list. It looks like we're permuting correctly. Now, the thing we need to do, let's make a new function called locate. So we're going to take a galaxy. We're going to read RC from 1. Let's see if this works. We're going to do locate on each of these. Locate. This is probably going to be slow, but I don't care anymore. Okay. Locate works. So now what we need to do is we need to manipulate the index to account for universe expansions. We account for universe expansions by checking E rows R, or I guess it would be this times 1,000,000. R equals that. Would it be plus R? I think it would be plus R. We can do equals with C. Oh, what has happened? Oh, what the heck? Wait, we still have that? Okay, here's where I have to actually think about the math. Well, I guess we can just check this example. What do? We do our distance algorithm now, and then we do sum. I have a feeling this is wrong. Oh, if it were merely 10 times larger, then it would be... Okay, let's try that with 10. No, that's not right. 558. Oh, wait. No, it'd be 1030. Okay. Oh, wait a minute. It's not 0 to index. So we need to start at index and go until the length of the line. Okay, this makes more sense, I think. Let's make a new variable called multiple. We can just subtract these at the end to make it less weird. So we're getting 68, but this isn't the real sample. Okay, now we're getting 1030, which I think is the right number. Part 2, 1030. All right, I think we're ready to send it. Ship it. All right, here we go. We're shipping it. Please give me a number. I think it might be this subshell here. Oh, there we go. It's just a little bit of a wait time. Are you trying to brute force the whole galaxy? Maybe. Turns out doing it smarter was the solution after all. But we do still have this one running. So I'm gonna leave this running for the rest of the lifetime of the universe, and we'll see if it terminates.